So today I'd like to be talking under my topic of misunderstood herbs, not a single herb, but a class of herbs, and that is the herbal class or action class known as the expectorant herbs. I think there's a lot of woolly terminology and quite a bit of misunderstanding of how best to use them and indeed what they actually do. So let's drill back to my experience as a student. Almost 40 years ago, I had the privilege of meeting the oldest herbalist in his village, in fact, probably the oldest herbalist in the UK at the time, at his village in Lancashire in the UK. And he had the wonderful name of Ernest Cockayne. That's a fantastic name for a herbalist, isn't it? Maybe I can change my name by deed poll. It's spelled with K's instead of C's. And he leaned over conspiratorially to me and he said, you know, I can't do a Lancashire accent, so I better not try. I found one of the best things for asthma was a weekly dose of a herbal emetic. The vomiting would be accompanied by a massive freeing up of mucus from the lungs. You should have seen what my patients coughed up afterwards. They loved it. Unpleasant as it sounds, he made a good point that one of the best ways to clear thick and stubborn mucus from the lungs is to give people something that makes them throw up, especially a herbal irritant of the stomach. And I can explain why. And indeed, what's old is new again, because we can exploit this phenomenon in a modern context where we're not having people have to, of course, vomit. So traditional herbal strategies for treating lung diseases are founded on supporting and strengthening the innate protective resources in the lungs. And particularly it's this clearing of mucus or expectoration that is a central concept. Unfortunately, it's had a lot of bad press in mainstream areas and is largely disregarded. And so it's one area where the divide between traditional and modern approaches is particularly great. In fact, modern medical science, which first embraced expectorants in the earlier part of the 20th century, now sees no role at all for their use. Part of this comes from a confusion over terminology and testing. What is it, an expectorant? So if you look at a dictionary definition, it's only concerned with the actual oral removal of the phlegm or sputum from the lungs. But the majority of mucus produced by the lungs is swallowed, and especially when you're asleep. So this definition is clearly unsatisfactory. And when they began doing scientific experiments to see if different treatments did increase expectoration, they were often only looking at what the person actually coughed up onto a tissue or a handkerchief, not necessarily what they were swallowing. Also, this highlights another problem, and that is, well, how do you measure and assess if an expectorant is working? So the modern dismissal of expectorants also stems from around the difficulties involved with measuring their efficacy. So along the lines of how an emetic stimulates expectoration or clearance of mucus from the lungs, I'd like to discuss this concept of a reflex expectorant. You'll often see in the herbal literature other concepts being used like stimulating expectorant and what have you. To me, they have little informative value and therefore add to the misunderstanding. So the concept of a reflex expectorant was in vogue in the first half of the 20th century. And the theory was that these reflex expectorants were actually emetics in higher doses. But in lower non-emetic doses, they act on the nervous system, causing irritation, or they act on the tissue and the nervous system in the upper digestive tract, causing irritation in that part of the digestive tract. And this then causes a reflex effect from the vagus nerve that flows out to the lungs, leading to more mucus secretion and expulsion from the lungs, hence reflex expectorants. Now, we know in many, many lung disorders like chronic bronchitis, even acute bronchitis sometimes, asthma, bronchiectasis, smoker's cough, that there can be this abnormal mucus that can be thick and tenacious and very difficult to clear from the airways and very irritant. So it causes cough, 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 chronic coughing. So the concept is that if you give a reflex expectorant, it will stimulate that mucus secretion and the expulsive mechanisms via the cilia, via the vagus nerve, and get an effect on the lungs. So you're getting an effect on the lungs without any of the key phytochemicals in reflex expectorants going anywhere near the lungs. They're actually acting on the upper digestive tract and causing that reflexive response, which helps clear the lungs. To me, it's clearly obvious when you give an emetic, as per my opening slide from the experience of Ernest Cockayne. But what about at subemetic dose? Is there proof that reflex expectorants work at subemetic doses? Can you still get a beneficial expectorant effect? Well, certainly this is supported by lab models, and there's the references there, but I do discuss this also in chapter 2 of Principles and Practice of Phytotherapy. It was researched in the 1940s by a Canadian scientist using several lab models, and he was able to show that saponin-containing herbs, so they're soapy, and they therefore have irritant properties on the upper gastric mucosa and stimulate the nerves and stimulate that reflex effect. They certainly are gastric irritants, and also ipecac, a well-known emetic due to alkaloids it contains. Both of those herbs exerted expectorant activity in his experimental models at subemetic doses, and he measured that by an increase in respiratory tract fluid. So I mainly rely on saponin-containing herbs for this reflex expectorant effect. And you can tell a good reflex expectorant saponin-containing herb when you get the liquid and mix it with a small amount of water and just swallow it slowly so it goes over your throat. And if you notice a fairly intense irritation at the back of your throat, you know that's going to do the irritation further down to get your reflex expectorant effect. Now, that's all very well, but it relies on the vagus nerve. So the vagus nerve in the lungs innervates the large mucus secretory glandular structures. But the lungs are also lined with many isolated mucus secreting cells known as goblet cells. So what do we do? Is there a second key mechanism that we can exploit to improve the mucus secreting properties of those cells? And the answer is yes. There is another class of herbal expectorant here that we can call secretory cell stimulants. And as you can see in the image, these are largely based around essential oils from various herbs. And you can either administer them as the oils, or they can be automatically there in a herbal extract or tincture. And what happens is when the person ingests that essential oil via the herbal extract or as such, it gets absorbed, it travels around in their bloodstream, and because they're volatile, these essential oils are volatile, a percentage of them, it's exquisitely small, but the goblet cells seem to respond best to the lower levels, according to Boyd's research. these essential oils are exhaled by the lungs, and that has been shown in later German experiments, for example, with thyme essential oil. Again, I think that's mentioned in chapter 2. And they can directly influence these isolated goblet cells to secrete more respiratory tract fluid and mucus. So is there any evidence for that? Well, yes, Boyd did research and he studied the effects of several essential oils in various experimental models. He did both inhaled and ingested. Now, the interesting thing was, in terms of an inhaled essential oil, lemon and probably therefore lemongrass was one of the most active. But what he showed was if the amount gets too high, if the essential oil gets to the point where you can smell it fairly strongly, that's too strong for the lungs and it won't increase the mucus secretion. It's almost at these olfactory levels that the inhaled essential oils will work. So if you're using it, an essential oil vaporizer at night, it doesn't need to be strong if you want this effect in the lungs. But what I'm looking at more here is the research he did on the ingestion of essential oils. And he found that the most powerful ingested essential oil via the herb or as the oil was the essential oil of anise, in other words, aniseed oil. But fennel oil has similar effects because it's quite similar. So when I treat patients with breathing difficulties and chronic cough, I always combine the two types of expectorants, the reflex expectorants, and any good saponin herb will do there. I, in fact, use horse chestnut liquid quite a lot for that. And it has this reputation for veins and all these things, but it works really well as a reflex expectorant. The old-fashioned Seneca, Polygala Seneca, if you have access to that, that's another example that you can use. But you can do the back of the throat test to assess, and you'll be surprised. There are quite a number of these saponin-containing herbs that would have this reflex expectorant properties. But I also combine it with these essential oil stimulants of goblet cells. So particularly fennel oil, but other essential oils that have a reflex, an expectorant reputation. They're not reflex, an expectorant reputation. You can do them as well. So thank you. And that's Grindelia, which we suspect is working as a reflex expectorant due to in this case, not saponins, but the resin that it contains.